Okay, so uh, problem number 2 is about fire alarm system. Now, this particular problem has a different condition with that of the first problem. So for now, allow me to show to you the Siemens ladder equivalent of this particular problem. And later on the next video, I will show to you the solution of this particular problem. Okay, so for network number 1, which is represented by the output is represented by the pilot light. So how do we draw the Siemens ladder equivalent? So again, normally open contact, and then another normally open contact, and then we have the output, no? And then again, another normally open contact, another normally open contact, and then up arrow. Okay, then here another normally open contact, then open contact, then up arrow. Okay, then open contact again, another open contact, and then up arrow, and then we have another open contact, then another open contact, then up arrow. Okay, so this is for network number 1. So we represent the inputs here with I 0.1. Okay, based on the problem, we have I 0.2, and then this one here is I 0.1, then I 0.3, and then we have I 0.1 again, and I 0.4. Okay, the next level, we have I 0.2 and I 0.3. Then the next level is I 0.3, and then you have I 0.4. So there are 4 switches or sensors to be exact, and these sensors can be a temperature sensors with different temperature conditions. Okay, the output here is Q 0.0, which represents the pilot light. So for network 2, we have again a normally open contact. Okay, then another normally open contact, then another normally open contact, and then the output. Okay, then you have normally open contact again, normally open contact, normally open contact, then up arrow, and then we have another level, normally open contact, normally open contact, and another normally open contact. Okay, then up arrow. Okay, then we have another normally open contact, then open contact, then another normally open contact, and then up arrow. Okay, Then we represent this with I 0.1. Then this one I 0.2. These are the sensors I 0.3. And then the other one is I 0.1 again. Then I 0.2. And then I 0.4. And then the other one is again I 0.1. Then I 0.3. And then I 0.4. Then this one here is I 0.2. Then I 0.3. And I 0.4. Okay, so the output here represents the output siren, that is Q 0.1, for example, no? And then for network 3, we have here normally open contact again, another normally open contact, then another normally open contact, then open contact, and then output. Okay, so this one here is represented by I 0.1. Then you have I 0.2. Then I 0.3. And I 0.4. Then the output here that represents the fire department is represented by Q 0.3. Okay, so then next is you try to, in the previous problem I was not able to compile the problem, but basically after making the program, just press the PLC here and then press compile. Okay, then you will show you will be prompted here with the number of errors. For example, if you have make a wrong program, then an error will occur in this particular area. So in this case, our program was correct. So you have 0 errors. Okay, so how does it work? Now, according to our problem, if any one of the input is on, then nothing happens. Okay, if two of the inputs are on, say for example I 0.1 and I 0.2, this will energize. So in other words, the red pilot lamp will lit. And then if you have I 0.1, I 0.3 will energize, Q 0.0 will lit again, and so on and so forth. So if any two of the four inputs are on, and then the pilot light will turn on. Okay, so that's the condition for the first output. The second output has the condition wherein if any three inputs are on, then an alarm siren will sound, no? So if any of the three, no, say I 0.1, 0.2, and 0.3 will turn on, then Q 0.1 will energize, and so on. So these are actually sensors, no? These inputs here, I 0.1 to I 0.4, these are actually temperature sensors with different temperature conditions. Okay, so when a particular condition, a particular temperature condition is obtained, for example, for I 0.1, 30 degrees centigrade, then I 0.1 will be energized. If the if another temperature sensor is is required. For example, it has a requirement of 40 degrees centigrade, which represents I 0.2, then I 0.2 will be energized, and so on and so forth. So it has a different temperature conditions. Now, if all of the sensors will turn on, then the fire alarm system will notify the fire department, okay, which is represented by Q 0.3. Okay, so the question here is, what will happen to the pilot lamp here, Q 0.0, if three of these sensors here will turn on? So aside from the sound of siren, it will also turn on the pilot lamp. Okay? So, sa duha pa lang gani daan, pilot lamp pilit, when tulo na, then the siren will turn on or resound. And then if four of these switches are closed or temperature sensors are closed, then your Q 0.3, which is the fire alarm department, fire department will be notified in this particular case. So it has a different condition with that of our first problem. Again, as I've said earlier, the solution for this will be shown in the next video.